it. So, happy garbage day for the last time this semester.
Last class?
Happy garbage day. It's the last happy garbage day. Yeah, don't get too excited there, pal. Like, what? No, you have to put up with me for one more day after this, and then you're home free, okay? That's the rules. I've got some announcements to make, and then I'm going to turn things over to Bladimir to lead your formative assessment. So in just a few minutes, there's your cue to enter, stage front or whatever this would be. First off, so I did some updates to the website. So I have put together a finalized printable version of the syllabus for this class that you can download and save. I do that for two different reasons. One is for future Lisa, to look at what actually happened and then plan the next version of this course accordingly, as opposed to all the things that I wanted to shove in here. I didn't get too far off, though, this time. I was pretty happy with myself. I finally learned, I think, what I can pack into a semester. The other is for you. So if you ever need to show a syllabus as evidence that you've been through similar coursework or, to get credit towards something, then you have the most recent version of what happened that you can download. I turned back your homework 5, so you all should have gotten feedback from me if you submitted it. If you did not yet submit, that's okay, but please try to do so by Friday. If you give me something by Friday, I promise I will turn it around over the weekend and give it back to you on Monday, which would give you all of next week to do a revision if you choose. After that, I will try to get to it as quickly as I can, but I can't make a guarantee based on all the other stuff that's, all the other fires that are being put out this time of year. Let me know if you have any questions about what you should revise, or if you need help troubleshooting models or any of that kind of stuff. On Monday of next week, I had to move my office hours. So normally office hours on Mondays are from 3 to 4:30. Next week, they will be from 1 to 2:30 instead. Our department is undergoing an external review, which we have to go through every 5 or 7 years. Nikki probably knows. I don't know, 5 to 7 years, something like that. And of course, they put a meeting that I'm supposed to be at during my office hours. So given that nothing else is happening that day in terms of all the other stuff, I decided just to move the hours. And then I have office hours when I would normally be teaching Tuesdays and Thursdays, regular office hours on Wednesday, and then after that, everything needs to be submitted on Friday. I will grade what's left, and I'll let you know when grades are posted. And I've made the executive decision, Nikki and Vladimir, you're not holding office hours next week, okay? You got your own stuff to do. So it's just all on me. But I will be on email frequently. I know everyone's busy and trying to wrap stuff up, and so I want to help you as much as I can to put everything into the done column, as they would say. I had some folks have questions in office hours. I had asked people to do track changes, and that necessarily isn't something everyone knows. So I wanted to show you how to do that in case you haven't seen that before. Maybe. Words like, no, I'm not going to open for you. Sure, I will open up the SEM example that I just did in the last class. So track changes is an option that shows up under the review tab. So there's a button called track changes right here. And once you click it, then anything that you type is automatically marked like this in a different color font with an underline. And you can pick whatever color you want. I don't really care. But this allows me to very easily see what you changed in response to my feedback. Some journal editors want you to use track changes when you revise a manuscript for the exact same reason. It's easier for the reviewers to just be like, okay, did they fix this? Did they fix this? Did they fix this? And it's also to make sure that I don't hold you accountable for anything I missed the first time. So please leave my comments in so that I can see what I asked you to change. If I missed something that you didn't do, I don't want to penalize you for it from doing the revision. So please do those things to help me help you, if at all possible. Also, for those of you who have done equation-y type things, make sure that you have subscripts and superscripts correctly. So like if you have, yi like that in an equation, that doesn't look like an equation yet. But if you turn y into a subscript, there's 2 ways to do that. One is keyboard shortcuts, control, and then the equal sign. So if I type the I in there and do that, control equals turns it into a subscript. If I do control shift equals, it becomes a superscript instead, like for R square or those kinds of things. The other way is to use the equation editor, which is alt equal or insert equation, and then to do subscripts in that, you use the underscore key followed by whatever subscript you want, for instance, and then hit enter, and it will jump into a thing like that. And you can also easily do Greek letters without having to hunt for them in the symbols menu. If you do a slash and then the letter that you want and then hit space, it will turn into the Greek letter. So these kinds of things make your equations look nice. They keep them very readable. And if you're writing equations, I would encourage you to do so in this kind of professional way. All right, any questions on that? All right, how is homework 6 going? It's not going? That's fair. I appreciate the honesty. You have like almost 2 whole weeks to get it done. So more like 10 days or something. But if it's not done yet, that's fine. I just thought I'd ask. So this homework is different than the others. If you haven't opened it, it is one giant path model. One model. So you will spend all of your time trying to figure out what the path model should look like and to get it right, and then you can dive into the results. And it is based on a true article in which they fit 2 path models for no apparent reason, and we're asking you to put them into one model. So you can use this article as a baseline for what the structure would look like. I would highly, highly recommend making yourself a picture, even with just pencil and paper, of what it would look like, and then writing the code from that. That's how I do it in practice when I do these things. So I have a whole list of what should be in your model and what shouldn't be in your model and how to do it. You can use R, Lavon, Stata's SEM package, or M+ to do this. All 3 answer keys have been checked. You should have access to all of those software packages within the virtual desktop as well. If you don't, let me know. And then, you'll like this part the best. Rather than result sections, there's just multiple choice questions. So they should be less confusing. They're straight out of the notes. They're straight out of me coughing and saying homework question periodically. You'll hear more of that this week. So these ones should be, I think, easier to tackle than the traditional where you're buried in the weeds of whatever the story problem is. So no questions on that as of yet? One question as of yet. Go ahead.
It's question number 3. So it's asking the number of pre-estimated parameters.
Mm-hmm.
And I also looked at into the example file, and I'm using Stata.
Okay.
So I saw that you are showing that answer in N+, but I could not really find it in Stata version. So can you explain what that is and then how I can get it from Stata?
Yes, so the question was, how do I get the number of estimated parameters and this? And so M+ calls them free parameters, which means free to be not 0, but estimated means how many degrees of freedom did you spend out of the number possible? Let me show you where that would be in what we've done thus far. I'm pretty sure it's in example 5. Wait, or not. Please? It's like, no, I'm not going to open anything while we're working. There. It's thinking about it. The hourglass means it's thinking. There. It is not something that is printed by default. It's something that I had to find and add for this very reason. But I will show you where that place is. So this is example 5, which we've been through. We're going to do 6a today, which you'll see again. Let me get all the way down into the Stata output. So for example, model 3 in part 2 is the first one that we had. It is down here, that line of code right there. So what this is doing, all of these statements have the same structure to them. Display means just print this to the output. That's how you can make it into a calculator if you tell it like what you want to do. So this is just a label that I'm adding. Number of parameters, and then E is like a piece of information that is stored internally to Stata that you don't have direct access to until you ask for it. So I had to look through the user manual. It saves it as this thing. So if you run this right after the model, you should have the number of estimated parameters come out with this, just this one function. Also, the log likelihood for the H1 model is another thing it doesn't print, but it's buried in there, and I found it.
So use that command right after the model.
Yes, so this is the model up until this much, right? That's telling it what model to run. Then this is all extra pieces of output. So the lincoms are extra, slope differences, labels for things, the standardized solution, the fit statistics, and then all this extra stuff right here. Okay,
Thank you.
you're welcome. Any other homework 3 questions? Or nope, homework 6. Homework 3 has sailed. Okay, no one's looking at me. I know a way I can make you look at me.
Lisa,
Yeah?
I have a question. What homework is this homework based, or what example is this homework based on?
It could be either 5 or 6A. 6A has mediation, which we're going to start today. And I believe I added that to, yep, the webpage. So this one is based on Example6a, which we're going into today. It's really just the indirect effects that we did that are new relative to what we did in Example 5. But I want to make a deal with you. This is my numbers so far for course evaluations. So the university, about a week ago, sent you an invitation via email to do university course evaluations for this course as well as for all of your other courses. And if you look down at this list here, you will see that my response rates are exceptional. 96, 86, 88, 91. My best one ever, fall 2020, 100% in both. Yep, and several people were in those classes right now, so thank you. Do you know how I get these extremely high response rates? Not ratings, mind you, response rates. I bribe you. Excuse me, no, I offer additional extra compensation for time out of class and working. That's what it would be called. It's like overtime if you have a job, right? I'm offering you overtime because I value what you have to say. So here's the deal. If at least 11 of you complete a university course evaluation, everyone gets 1 extra point, extra credit point, added to your numerator, not the denominator. I don't want to be automatically logged out, but it's okay. So that's part of the deal number 1. If I can get to at least 11 out of 13, all of you get a point of extra credit. I do not know who has completed an evaluation, but as you can see, I have the capacity to email reminders. So it knows who has done it, and it will email the people without me knowing who they are. So this is open until Saturday night at midnight. So you have a few more days to complete it. I'll send out a reminder probably Friday morning just to make sure. But that's only part of it. So the university course evaluations do not offer any opportunity for customization. They have generic questions that are assumed to apply across all the classes, graduate and undergraduate. So for me to get more detailed, targeted feedback, I have a second course evaluation that I do via Qualtrics. Tomorrow morning, each of you will get an email from Qualtrics inviting you to complete a survey for this course, and everyone who does it gets another point of extra credit. So up to 2. The way that it works inside Qualtrics is that I feed it a list of emails, it sends it out to you, and then it tells me on the back end which emails have completed a survey, but it doesn't tie your responses to your email. So that means it is as anonymous as it can be. So I want you to feel free to be as upfront and forthcoming as you wish, but these questions give me a much more targeted way to assess how the class went, as well as to get your suggestions for things to change. I do try to make changes when I'm able to based on feedback, and I've gotten a lot of really useful feedback. Ironically, this is the one instance in which I consider myself a qualitative researcher, because the numbers really don't help me, right? It's like, on a scale of 1 to 5, how much did you like this? 2, I didn't like it. What am I going to do with that, right? That's not helpful. But if you can write in the text box, I did not like this, and I wish it would have been this way, then I can at least consider whether or not I want to make such changes. But people have given me really useful feedback in the past, and I value your time in doing it, which is why I offer additional compensation for time spent outside of class. So just to recap, 11 out of 13 university course evaluations by Saturday. Everybody gets a point or extra credit. If we don't hit that mark, we don't. But each person who does a Qualtrics survey evaluation by the end of finals week, so I'm opening that up for longer, will get 1 point extra credit for your own self. What do you think of that deal? You like it? So maybe that takes a little bit of the pressure off if you're stressing about trying to get everything done perfectly. Perfect is never the goal. It's the enemy of good, in fact. So I will let you know on Thursday how this is going. Give you an update. The other class is off to a good start, but you want to beat them, right? We can offer a little inter-class competition. In the meantime, we've got formative assessment number 6 to talk about, right, Vladimir? Are you ready to do?
Yes.
Okay, then he's going to come up here and take over for a few minutes. And we'll get me and my shoes out of the way. It's hot. I'll take my shoes off. There you go. Make sure you're either in the frame, if you want to stand up, or sit down.
Yeah, I stand up.
Stand up, okay. Actually, I don't have the frame on.
It's okay.
I didn't want to look at myself. The others can tell you.
Yeah. So we have. So how can I know? Can you see me well, Nikki? I don't have access to this camera.
Yeah, I turned it off. I can turn it back on.
Yeah, I'm trying to see, but can you see me well, Nikki?
Yeah, we can see.
Okay, awesome. Thank you, Dan. That's okay.
Well, it's this one. Hide self view is the option.
Wow, that's too tiny to me.
There you go.
Thank
See?
you. Yeah,
Short
so
people.
now I can know that you can see me. Great. Thank you so much, Lisa. Hi, people on Zoom. This is me again. Hey, hi. Good afternoon to everyone. Happy Garbage Day. I like to say that too. So I hope you are doing well. This is the last formative assessment we have. That means this is the last chance to me to talk in front of you, and I will take it. So today we will be covering 3 questions. I read your answers, so thank you for your responses. And we will be talking about some of the answers, and I have some notes that I would like to share. And I think that we can cover this quickly. So, first things first. Question 1. In what situations or types of research question is estimating multivariate models using path analysis a better strategy than tricking univariate software into doing multivariate models? What do you think? What are some scenarios where path analysis is better compared to tricking univariate models?
So tricking univariate means stacking everything into one outcome and then using the DB dummy code to turn things on and off. That's what that refers to.
Yes. In both cases, we are in the multivariate scenario, but there are some advantages of using path analysis instead of the first option. What do you think? I have 3 ideas here, potentially 4, and I read many options. So, comments, thoughts, impressions?
Well, the variable is both the predictor and also an outcome.
Exactly, yes. When we want to predict some of our outcomes, well, when we want to treat one of the predictors as outcomes, we would need path analysis, because in that case we can allocate that predictor in the joint likelihood in our model. Now, refer to that is also important when we have some missing data in our predictors. So using the first option, tricking the univariate software, we would be using or assuming missing completely at random. So in that case, we would be dropping that information. However, when we treat our predictor as outcomes, we can recover part of that information, assuming missing at random, data missing at random. So conditional on the information we have, we can include that missing information in the model. Yes? So, yes, there we have two things. There are other 2 that I would like to mention. But first, other ideas when we want to treat models as predictors as outcomes, that's one. And also when we have missing data in our predictors. There is one that I read a lot that I think is correct. One of the things that I read and I agree is this idea of when we have complex relationships between multiple variables. So in those cases, to me, if would be easier to use path analysis to see what kind of relationships we are including in our model between the outcomes and predictors we are included. So from that perspective, if the model is complex and you are not interested like in a specific dependent variable differences or coefficients, I think that path analysis is a good option to represent the kind of relationships you are interested in. Now, the other option is when we are interested in mediation. We cannot do that when we are using the first option, when we are tricking the univariate software, because in that case we have only one column with all of the outcomes stacked. So mediation is not a thing in that option. However, when we use path analysis, we can create direct and indirect paths. In that way, we can test mediation between outcomes. The other thing that I wasn't aware of until I talked with Lisa, and this is part of the slides, it is that when we use the first option, when we trick the univariate software, we are constraining some of the parameters in our model to be equal across the different outcomes. So for example, if we have different outcomes, count outcomes, the over dispersion parameter would be the same in the intercept. We don't have an alternative to release that parameter. So the outcomes would have the same over dispersion parameter, something that we can do if we use path analysis, because each outcome would be treated as an outcome independently or by itself, right?
They have its own parameters.
Yes, the outcomes will have their own set of parameters. So that's another advantage. Questions, comments about question 1? I think that's clear, right? What do you think? Do you feel okay with that? Good. So, question 2. Describe how total and model degrees of freedom are determined in path models. In what scenarios is absolute model fit testable with respect to model degrees of freedom? So, first, what is total degrees of freedom? How can we compute that? Or what is that? Total degrees of freedom. Yes? Yes, exactly. The total degrees of freedom are the total parameters that can be estimated in our model. That includes intercepts or means, variances or residual covariances, and covariances. So based on the total thing that we can estimate in our model, we can compute the total degrees of freedom. Now, something interesting is that we are considering our outcomes. And sometimes I know that when predictors are truly exogenous, just the covariances with the outcomes are included as model parameters, right? However, when we have endogenous predictors, so all of the relationships with the outcomes will count as total model parameters, because we are treating the predictor differently in both scenarios. It is not the same if the predictor is truly exogenous or if we are treating the predictor as an outcome, because in that case it will be part of the joint model log likelihood. Good. Now, that's one part of the question. What's model degrees of freedom? What's that? We have one part, total degrees of freedom. Now, what's model degrees of freedom? People on Zoom, you can also participate, of course. Yes, exactly. Degrees of freedom left over. So, in short, we know that the model degrees of freedom is equal to the difference between all of the parameters that can be estimated with respect to what we are estimating in our model. Now, if we are interested in testing absolute model fit, what do we need to do this? And this is related to 3 different options in our models. related to identification. So, what do we need to test absolute model fit? Is one of the things related to identification. Oh, why? Why do you think that just identify models are enough? That's a good follow-up question. Why? Because when we have just identified models, we are saying that all of the things that we could estimate are being estimated. Can we test fit in that scenario if all of the things that we could be estimating or estimate are in fact being estimated by the model? Can we really test fit? What do you think? If all of the things that could be estimated are being estimating in our model, can we test fit? What do you think?
The model can reproduce a perfectly.
Perfectly.
Exactly. What does it mean that? That the fit will be perfect. So
Zero
we
degrees
can,
of freedom.
yes, 0 degrees of freedom. So we cannot test absolute model fit. We can test it when we have some things left over that we could include if model fit is not perfect. That's the key. So, in what scenarios is absolute model fit testable? When our models are over-identified, because we have some things left over that we could include if that's necessary. Yeah? Does it make sense?
So just identify it's related to the total degree of freedom. It's not for the model degree of freedom.
Yeah, but remember that the model degrees of freedom is just the difference between the total degrees of freedom with respect to what is being estimating, or what was estimated by your model. So if the difference is 0, that means that in terms of degrees of freedom, all of the things that could be estimated were estimated because the difference is 0. In that case, the model will fit the data perfectly because we have all of the possible things already included. So we cannot test fit in that case. However, when the model is over-identified, there are some things leftovers that could be included in case fit wasn't met. Good. Yes.
Yeah, a regression model is just identified. Because each outcome, the one outcome, gets an intercept and a residual variance, and all the relationships between the predictors and the outcome are in the model. So that's not even a thing in regression. You've never heard those words because they don't apply. We don't worry about fit in trying to reproduce the relationships. They're going to be reproduced. In this
Exactly.
case, if you leave out some stuff, maybe you're wrong. The question is, are you wrong?
Exactly.
That's model fit.
Yes.
Are you wrong to leave things out?
Yep. That's a good example. So, how do you feel with this? Are we okay? Some nodding? Good. Finally, question 3. How is it possible that you can achieve excellent absolute model fit yet have none of the direct paths or covariances in a path model be significant? How is that possible? What do you think?
And by the way, I meant not significant as in like low effect sizes too, like small relationships that are not equal to 0. That was the idea. I should have phrased that better.
Yeah. I think the question works based on what we discussed in our last class. So, what do you think? I read many things and I read some good answers. So, here I have like a key idea that I extracted from one of your answers, but do you want to share something before? Because to me, based on your responses, I think that a good short answer would be that this can be possible due to weak relationships or small effect sizes in our data. To me, that's fair, and that would be enough. Why? Because remember, as many of you said, model fit is related to how the model is reproducing the observed things in our data. However, if those things from the beginning were not a thing, if the variables were not related to each other from the beginning, so they won't be significant, right? Or maybe the effect sizes were not enough to be identified by our model, right? And I remember one phrase that I think that you said last semester: garbage in, garbage out.
That sounds like me.
Yes. To me, when I read this question, I remember that because um, that's 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 a possibility in research. If the variables are not related to each other, if we don't have something to say about them, if the model fit perfectly, it doesn't mean that we have something there, because we are not changing what the relationship between our variables are. So with respect to that, I think that the answer that I read makes sense to me. And I would like to say something else before finishing this, because I read some answers trying to relate sample size to this scenario. But that's another issue, because when we have large sample size, we have a lot of power to detect even small differences or small relationships in our variables. So that's slightly different, and maybe Lisa can help us with that. And that's all what I have. Comments, ideas, things to say. How do you feel about this? Good?
Does that mean larger power can be easier to detect the small effect size difference?
Exactly. Yes, and to me that's opposite to what to the meaning of this question, because if we have large sample size, we should be able to detect those small effect sizes because of power. So yes, what you said is right to me. With large sample size, we have lot of power, which means you can detect small differences or small effect sizes just because of the power the model has. But I think that here we are talking about a different thing. Maybe when we have small sample sizes, some effect sizes couldn't be statistically significant. So that's another option. Yep. Thank you so much. Good to see you this semester. I hope. But we have one class more. Yes.
I know, everyone's getting excited.
Yes. Thank you.
We're almost there, but not quite. Thank you. Dang, he's tall. There you go. Bring this back down again. There we go. So yeah, the power thing is different. So if you think about this in the context of, like, let's say you're interested in showing that two things are not correlated. That's your research hypothesis. You are cheering for the null. The best way to find that out is to get very few people and have low power to detect the null. Then you win. So in the context of model fit, very few people means you lack power to detect a difference from the perfect model. So fit looks better because you lack the power to find a misfit. But at the same time, more people means you have more power to detect increasingly smaller effects. So they may be more likely to be significantly different than 0. So sample size works in sort of unexpected ways in this context. All right, and do I want to say anything about that? No? Okay, that's about it. Do you want to talk about mediation a little bit? Well, I made you do some indirect effects for your last homework, so you kind of want to talk about it. It is a thing. I have way more content on this than I want to spend time on, though. To me, mediation is regression with a better marketing campaign behind it. Mediation is all about whether you have a significant relationship between variables after controlling for something else, and that is regression. It's exactly the same set of concerns. There's just an additional set of language and procedures that goes with it in order to use that qualifying label as mediation analysis. Let me get rid of this, see if I get some more power here. Yeah, processing power works the same way. It's difficult to have many things open on your computer at the same time, even if it's a newer one. All right, this is example 6a that we're going to do today. Before we dive into that, though, I'm going to do a couple slides about power, because we need that, or not power, mediation. I'm scrolling ahead a little bit. So this is slide 40. So this is the classic mediation triangle. This terminology of X, M, and Y is pretty universally used to describe these kinds of models. But the idea of mediation is that X causes M, which in turn causes Y. So for instance, if I'm doing some kind of intervention that's designed to help children by helping their parents, then whether or not I'm in the intervention condition should lead to better parent outcomes, and better parents lead to better children. So the reason that the intervention works is at least in part because of its effect on the parents beyond just its direct effect on the children. That's the kind of design in which these things happen. Ideally, you would have longitudinal data with which to separate these things in time, but a lot of mediation analyses happen on cross-sectional data, so I will show you the machinery and leave it to the causal inference class and other coursework to be able to talk about how you would make these inferences causal as opposed to just associative. So this is the basic idea. So here is some terminology that you will need to know. So we start with the idea of the predictor X being related to the outcome Y, and note the direction of the arrows. This is called the C path because we go from left to right here, A, B, C. Mediation is the question as to whether the C that you had to describe this relationship before is different than the C that you get after you control for your mediator or mediators. Is C prime, as it is here, different than C? That's the question. The way that we assess that in old school land was directly to try to test C versus C prime, and then some genius figured out that in many cases, if you take the slope that is given by the A path label here and literally multiply it by the slope given by the B path, and that result, that multiplicative result is significant, that is the answer. C is different than C prime. So if you have an indirect effect that is significant, then the relationship between X and Y is different after controlling for the mediators than it is before. That's the whole idea. So you hear phrases like partial mediation or full mediation. Partial is when the relationship is still there, but it's reduced. Full mediation would be when it becomes non-significant. So historically, the way people have addressed this is by a bunch of piecewise regressions and then try to stitch the results back together. If you're going at it from that sort of step-by-step perspective, it is not the case that you have to have an XY relationship in the first place. It is entirely possible that this relationship is null, but then it becomes something else after you control for an intervening variable. So it really is about whether the relationship between X and Y changes after you control for something versus if you don't. But in terms of rules that should hold, in order for this to make sense, you should have a relationship between X to M that is significant and M to Y that is significant. Otherwise, there's really no chance for AB to do anything special. There is a whole lot of research on how to get a standard error for the difference between C and C prime and AB. And I'm not going to bore you with it. This is something that statisticians fight about, and I tried to care. I just can't. I can't bring myself to care. I just don't. I can't. In practice, I've seen these things differ in like the third decimal place of the p-value, and I just don't care. But in case reviewer 3 is a mediation expert and really cares, I will show you how to do the things like bootstrapping and all the stuff that is the better way to test significance. The issue is that the result of A times B is not going to be normally distributed unless both of these paths are 0. Or actually, no, especially if they're near 0. So the further over they get. So A to B does not have a normal sampling distribution, which means your typical way of saying estimate divided by standard error is supposed to follow some kind of normal distribution is not going to work. So that's where the problem comes in. So here's a bunch of options for bootstrapping-y things. Here's a link to Chris Preacher's website that has calculators and things for doing various other kinds of bootstrapping if your software doesn't do it. I'll show you how to do it in M+ as well. Okay. That's the short answer. Here's example 6a, which is based on a true story. This is a path model from one of my former colleagues at Nebraska who was a social psychologist. She specializes in gender issues, and this came about from a consulting meeting that we had. She had a manuscript in which she was looking at the relationships of these variables. So X is mindfulness, Y is warmth towards feminists. And the 4 middle boxes all sound like the same thing to me, but they're not to her. T's laughing at me, like, yeah. So motivation to respond without sexism, motivation to respond external and internal, hostile sexism, and then benevolent sexism, which is like when you take care of someone and you're trying to be nice because you don't think they're capable of taking care of themselves. And because all of these things sound the same to me, I labeled them, and this is what's in the manuscript, M1, M2, M3, and M4, so I could keep track of these variables. And in her original analysis, she had done 10 to 15 different regressions. So she did each of these pieces. Does mindfulness predict this? Does it predict this? Does it predict this? Does it predict this? Does it predict this? And then, does it predict differently for men and women? Does it predict differently for men and women? Does it predict differently for men and women? And the reviewers were like, oh my God, can you please just put this in one analysis? I can't keep this straight. And she's like, how do I do that? I'm like, this is how you do that. And after about an hour or so, she's like, that's it? I'm like, yeah, that's it. And she's off and running her own path model. She doesn't need me anymore. So that is my definition of success, is that y'all don't need me at some point. I make myself obsolete and unnecessary, then I know I am successful. So this is the link to it right here. This is, she was interested in mediation, so the extent to which mindfulness predicts warmth towards feminists differently after controlling for these 4 mediators. So in this analysis, there's 4 mediators, 1 predictor, 1 outcome. What is not shown in the picture are all of the covariances that will be estimated among the middle sets of variables in this case. Here are the correlation matrices. These are all subscales, by the way, that we're pretending are normally distributed. Don't yell at us. And the correlations are given by gender. So this is a binary gender assignment, above the diagonal versus below the diagonal. I have then the model itself. I have labeled in the comments. We'll start with Stata, and then we'll go to R in this one, what is happening. So mindfulness to warmth is the X to Y path. That would be labeled as C. X to the mediators, so these would all be the A paths. Then we have all of the mediators to the Y paths. So note in the code here, you can stack up multiple things being predicted or have multiple predictors. So I wrote this in a way that went from right to, or left to right in the diagram, but you can write it however you'd like. Now this X variable at the front of the chain here, she had a few people that didn't answer the questions. So if I were to fit a regression model, what would happen to the people who didn't answer the mindfulness subscale? Do I get to keep them? Nope, they're gone, right? But ideally, they gave me other information, so I'd like to keep them. So do you remember the trick that we talked about last week of how to solve this problem? We're going to pretend that this predictor is an outcome. And then you can have missing data on it under an assumption of missing at random, which is not testable. So functionally speaking, what we're going to do is fit an empty model that predicts mindfulness. What's an empty model again? This is like week 1. No predictors, yeah. So it's an outcome from the perspective of estimation, but I have to do air quotes because it's not an outcome of anything. It just means I'm asking for its mean as the fixed intercept and its variance to be estimated. And that brings it into the likelihood, in which case all of its associations with the other variables are then part of what needs to get found as the model solution. So each package has a way to do this. In Stata, it's right here. So in homework 6, I'm going to ask you to do this for predictors that have missing data, because it's a useful trick. This is why I've never once done a multiple imputation in my entire life. I do it this way. This is much easier. So I'm asking for the mean of mindfulness and the variance of mindfulness. And note that I have a C at the end of it because it's going to be centered. Because all predictors need to have a meaningful 0 point, and that rule does not change just because we're in path model land. So this brings the X predictor into the likelihood, allows for missing data. Then I'm asking for all the residual variances for everything that's being predicted. And I found this option within Stata specifically, covstruct, allows you to put a structure onto the residual covariances of a series of variables. And unstructured is a vocabulary word. What does that mean? We talked about it very briefly. Unstructured. What kind of pattern is that? Should I cold call on people? They're like, no. I'm going to call on T. What's unstructured mean?
I know what it is.
I know you know.
I know what it is. Oh my gosh.
You want to phone a friend?
No, no, I should know what this is.
You can phone the TAs, they'll know.
So, sorry, so unstructured is.
Think about longitudinal.
Yes.
Yep.
Yes.
That's a longitudinal term.
Unstructured is saturated. right?
Yeah. Everything gets to be what it wants is the way I always say that. Unstructured means let the residual covariances, all 6 of them, just let them be. So all possible pairwise covariances are being estimated separately among these 4 variables right here. And saturated is, I will accept that as a synonym. Yep, means everything that you could have is there. You spent it all. I am adding robust standard errors. So this is protection of the fit statistics if they matter, and standard errors against multivariate non-normality. This is usually a default when I try to do these things because multivariate normality is a fiction. It never holds. And in the event that it does, these simplify to just your standard errors. SStat T effects is supposed to give direct, indirect, and total effects in Stata. It's broken. It doesn't give the right indirect effects. It gives you blank lines. And I couldn't figure out why, so I made my own. So the next 4 things here are examples of how we build indirect effects, X to each M to Y. And these are the names that I had to figure out what it was called using COAF legend. But this is the path from mindfulness to internal motivation to do whatever. And this is the path from warmth to internal, so M to Y. So these are going to be my indirect effects. This is literally going to take 2 slopes, multiply them together, and give me a hypothesis test and a standard error for them. And that's the one that people say, you shouldn't do it that way. You should bootstrap it instead. And I'm like, whatever. You can also then sum all of those indirect effects. So that creates my total indirect effect. And I can sum that with this is with the direct effect, and this is total indirect. So all the things that this was supposed to give me, I can get through brute force. Asking for standardized output, asking for goodness of fit, and R² per variable. The full results from these models are available in the example files online. I didn't put them all in here because it was going to take too much. So relative to what the previous example had, this is the new part, this idea of asking for indirect effects to be computed for you. Okay, Stata folks, this looking okay? Yeah? Not a whole lot of Stata folks. R folks, who wants to learn how to use Lavon? Few people? This is the same model in Lavon. Note that I have labeled everything. So the parentheses, these are labels. So this is the intercept for mindfulness. This is going to give me the variance for mindfulness. So now I am bringing it into the likelihood. So by asking for, this looks like an intercept, but it's unconditional, so it's actually a mean. This looks like a residual variance, but it's unconditional, so it's actually just the variance. Now mindfulness can have missing data. So the rest of these then, the squiggle to a 1, those are intercepts. Squiggle, squiggle is either a variance or a covariance. If it's a different word on each end, it's a covariance. If it's the same word, it's a variance. Then we get into the paths, which, by the way, these paths have like 4 different names that they could be. What would you call it if you predicted y from x? What would you call the thing that does the predicting? Starts with an S. SL. Oh, slope, right? These are slopes. In this context, these are also called paths. They are called direct effects. And one more to add to the list from DAG, what is it? Directed acyclic graphs. Still going to have to work on that one. They're called edges. We're just going to relabel everything. So slopes, edges, direct effects, and paths are all the same thing. So I have labeled these with what they're supposed to be for. So x to y, x to m, and so forth. And then right side of the model, here's my comment to myself. These are all the m mediator to y paths. So warmth is the outcome, and then I'm stacking them up like this with the plus signs. So it is not doing literal addition. It's just adding more than one predictor of the same outcome. I know that's confusing, and I don't like it, but they didn't ask me. Residual covariances, I could not find any way to do this with less code, so I wrote them all out. I'm sure there's a way. I don't know what it is. At some point, you just give up and do it the long way. And then indirect effects. So these are new parameters being built out of the labels. So colon equal sign, not squiggle. So these are being computed for you out of the things you've already asked it to estimate. So x to m1 times m1 to y. That's my indirect effect for the first possibility. And the second one, the third one, I can add them up to get the total direct effects, indirect, and I can get the total indirect. And then they're literally just summed like that. I don't find those particularly useful, but in some disciplines they're a big deal. So all of this green text is an object that I have named syntax for single group, because right now we're lumping everyone together. And then I feed it into the Lavon function as the argument to the model option. Asking for MLR, so robust maximum likelihood, analogous to what Stata is doing in terms of correcting its standard errors, and then asking for all the usual path model output. And then I do have output from Lavon, since I know many of you are going to use this. Okay. Questions on that syntax are, folks?
So if you had more than one outcome, let's say,
Mhm.
like in a homework,
Hypothetically, yes.
hypothetically, so you would just like add those. So you'd still use this. Like you wouldn't do a separate model for each outcome, right?
Correct.
Yeah.
Yep,
Okay.
you just add them all in here.
Yeah. Okay.
Yep. Everything's happening at once. Yes, indeed. Other questions? All right, then let's look at what we got. So when you ask for robust estimation, you get 2 columns of output. One is unrobust, which is labeled standard, and then the robust column. So this tells you basically how different your conclusions would be with respect to your fit statistics. So fit actually looks a little bit, nope, this is baseline model. This is the fit of the null model. It's happier in it and robust. User model versus baseline model. This is the one that we care about. CFI is 1. TLI is 1. We go down here to RMSEA, it's exactly 0. SRMR is exactly 0. This is the best fitting model in the history of the world. Or, why does it fit so, I don't know, perfectly? Yeah, it's just identified. Meaning I spent everything. Every single pair of variables has something connecting them. Either a slope or a 2-headed arrow, meaning it's a covariance. So we have no room to be wrong. This model has to reproduce the means, variances, and covariances of these variables. Has to. The question we have to ask is, are they worth reproducing? Do we have a story to tell? That's a different question. This is the prerequisite to beginning to understand what the story is, that your model fits. We ensured that it fits by estimating everything we could. In the output then, So there's a section called regressions. Can you guess what these numbers are going to be? Under the section called regressions? Starts with an S. Slopes, yeah. Otherwise known as, what are the synonyms? One starts with a P. Paths. These are also direct effects and edges. Pick your term. And one thing that I really like about Lavon is it used my labels, right? So I don't even have to remember what my variables are called. I can just look at my own little notation here and be like, this is M1, this is M2. I like that. So the estimate column, these are unstandardized slopes, and then it attaches the standardized versions to the last two columns. So let's find this one right here. So this is mindfulness predicting internal motivation to avoid sexism. For every unit higher mindfulness, my internal motivation goes up by 0.33. It's just a slope, nothing new. There's no link functions even in this story. The standardized version of that, if I put both means to 0 and both variances to 1, would be a coefficient of 0.11. So relatively small effect, but we have enough power to find it, so yay us. So then each of these is organized by what is being predicted first, the y, and then what is predicting it, the x, is underneath. So the squiggles mimic what the code would have been to set this up. Warmth is the outcome, and here are the direct effects from all the mediators. And it looks like internal motivation to avoid sexism has a significant unique effect, as well does hostile, but external and benevolent don't. So to answer your question then, if we have lots of outcomes, you'll just have a lot more of these. And they don't always put them in the order you want them to, or the order you wrote them in. That's something that's frustrating to me about M+ in particular. So you may have to sort of search for a while. Covariances. These are relationships between the leftover parts of all of these variables. And I know that it's the leftover residual parts because of the dots in front of them. That's what it means. So these are residual covariances. Without the dots, they would just be straight covariances, not the leftover parts. Intercepts. So for instance, for internal motivation to avoid sexism, this is the expected score on this subscale when all of the other things predicting it are 0, which at this stage is just mindfulness. So these are interpreted in the usual way. These are variances. So mindfulness right here does not have a dot because it's not being predicted. It's in the likelihood. We're pretending that it's an outcome, but there's nothing actually predicting it. So this is all of the variance in mindfulness right here, as estimated by maximum likelihood. And then we get to R squares. Why don't I have an R square for mindfulness? Where did it go? It's not being predicted, so what's its R square going to be? 0, yeah. Homework question. Yeah. And then our newly defined parameters. These are my indirect effects. So the multiplication of the path from mindfulness to each mediator and from each mediator down to the outcome. That's what these numbers indicate. We can't really interpret them directly very easily because they're in two different sets of units. But usually what people care about is the p-value. And this is the thing that reviewer 3 is going to yell at you about if you report it straight up without doing bootstrapping or some other thing. But it's not going to matter. So we have 2 significant indirect effects, it looks like, out of the 4. So part of the reason why mindfulness and warmth towards non-traditional whatever were related is because of these 2 intermediate things. That's what we would say. Not so much because of these other 2. Okay, how are we doing? M+, folks? Anyone want to learn M+? Here's what it looks like in M+. So this is the script. You have to tell it what your variables are in order in which they appear. Then you have to tell it which ones you want to go into your model. Each of these names needs to be 8 characters or fewer. Here are the options to turn on bootstrapping. You can't have MLR estimation and bootstrapping at the same time, so I have those commented out. If you wanted to do that, you would switch the other way. Same thing with the These are this is a BC Bootstrap special confidence interval version of it. I don't remember what it is, and I don't care. But if you need to know it, it's right here. So in M+, on is the equivalent of single squiggle. With is a covariance. So the first step is to bring the predictor into the likelihood by asking it to estimate its mean and variance. So that's right here. So for all of these things, when you list a predictor in brackets, you're referring to its mean or intercept. When you list a predictor by itself, you're referring to its variance or its residual variance left over. So mindfulness is now in the likelihood, allowing missing data because I brought it into the model in this way. Then we get intercepts for the other variables, residual variances for the other variables. I've labeled everything just for the sake of completeness. Direct effect of x on y, direct effects of x on the m's, direct effects of the m's on the y, and then here is how you do all possible covariances for a series of variables. You stack them up with stack them up. Then model constraint. So this way of asking it to multiply the A and B paths together works no matter what kind of model you have. If you have a multivariate single level path model though, there is a built-in thing you can do instead called model indirect that's a lot less typing. And the way it is y, IND stands for indirect, and then x. And this will give you all of the possible indirect effects without you having to identify them and label them. This only works sometimes. So to be able to do it more generally, I'm doing the exact same kind of nonlinear combinations where we have the 4 indirect effects that I'm creating as multiplicative slopes, A times B for each of these, and then total direct and indirect, and then total direct, indirect right there. Okay, questions on M+ syntax? Now M+ has no flexibility in the order in which you write the ons. It has to be y on x. The other packages allow you to change it around. So I'm writing it as y on x to be consistent across all 3 sets of code. And I have SAS in the online files too if you want to learn how to do path analysis and proc calis. 4 different packages. Here's my model fit. So here's how you will know for sure if your model is just identified. Which one are we? Remember the story? Are we the HO or are we the H1? We're the HO, right? But in this case, it's the same number. That is not a coincidence. If your model is just identified, the height of the best possible H1 saturated model where every parameter is spent is going to be the height of your model. So you will know if you're in just identified territory if these 2 things match. The rest of it then is a consequence. I'm not wrong at all. I have no room to be wrong. I have no degrees of freedom. I spent them all. The number of means, variances, and covariances is equal to the number of estimated parameters. Intercepts, residual variances, slopes, and residual covariances in this case. Here are the unstandardized results. M+ does not use the labels, unfortunately, but this is all of the stuff predicting y. This is the x to m section. Then we get into the residual covariance section. So it's reordering it relative to what I asked for, just to make my life harder. Means versus intercepts. This is the analog to the dot or no dot in Lavon. So mindfulness gets a mean because nothing is predicting it. The other variables get intercepts because they are conditional means, conditional on any predictors being 0. Likewise, mindfulness gets a variance because nothing's predicting it. The other variables get residual variances, which is the leftover variance after being predicted. Here are my indirect effects under new additional parameters. Same results. The first and the third indirect effect are significant, it looks like. The others are not. And so I have highlighted down here, this is the total indirect effect. These are all the other things it would print for us by default. So in this case, it gives you all the indirect and total effects on that. And I got them myself by adding stuff together. I didn't ask for that in your homework, but I did ask for some indirect effects, so you can learn how to do that. Ta-da. There. So let me go back to the picture. This is what we did. We put a table in the manuscript that had all the results on it. Otherwise, I could put coefficients onto these lines if I wanted to, using little text boxes. But this doesn't address anything about gender differences. She wanted to know if these patterns of direct and indirect effects differed between men and women. So that was research question 2. How do these patterns of relationship differ by binary gender groups? What does that part sound like? If you want to know if slopes differ as a function of another variable, yeah, moderation. But I'm already doing mediation. Can I do both at once? I just did. Gonna. So no, this is another thing. This is going to be called moderated mediation. There is also such a thing as mediated moderation, and they are not synonyms. I have a hard time keeping them straight, but I'm pretty sure I'm going to do moderated mediation. So there's 2 ways that you can do it. In these models, I would have to add, one way is to add another box in here for gender. And then I would have my gender box predict everything as a main effect. And then what would I need to do to add an interaction term? What do we normally do? We just put it in the equation, right? Well, how do I translate that idea of a slope for these 2 variables multiplying each other into my picture? I would have to make an interaction box. I would have to make a new column in the data set that is the product of the 2 variables that I want to test the interaction for, and I would add that as another box. So I would have a gender box, and its slopes would predict all of the variables as the main effects. I would add another interaction box, and those slopes would carry the interaction terms. And this was the point where the reviewers were like, no, 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 no. But what if I told you there was an easier way? Would you like that? Who's going to say no to easier? If your moderator is a grouping variable, it's a lot easier than that. At the end of it, what an interaction term does is allow main effects to differ as a function of something else, right? So I might have a man slope and a woman slope for each of these variables. In that case, what I can do is say, hey, can you make this path model go just for the men and just for the women, but do it at the same time so I can see how they differ? That's called a multiple group model. And conceptually, it is the same thing as adding a gender box and all of its slopes as its main effects, and interaction box and all of its slopes as interaction terms. But it's a roundabout way of doing it. What we're going to do on Thursday, because yeah, you have to come back and see me one more time, okay? But then you don't have to see me until August, or maybe never ever again if you don't want to. Because all of my classes are optional, right? That's the lovely thing about it. We're going to say, hey, make a path model for men, make a path model for women. And then I'm going to ask, is this slope different than that one? If the answer is yes, that's my interaction term. So each of the slopes within the separate models are going to be my simple slopes, conditional for each gender. And then I can have not just simple slopes and interaction terms, but different indirect effects by gender, right? Because I can ask it to do this multiplication in men, this multiplication in women, and I can compare those results. So that's the extent of differential mediation by group, moderated mediation. But we're going to do that on Thursday. And then we'll see how much we can cram into Thursday, and whatever I don't cram, I can make a video about. And you can catch up on your own later. So that's where we're headed, is multiple group models. And to do this in Stata, that. One line. Group. Meh. Give me 2 of them. To get all the different indirect effects, a lot more lines. So, all right. Questions or comments? Hopefully this will get you started on homework 6. It's a single group analysis, some direct effects, some indirect effects. One model, that's it. Let us help you if you need it, okay? Don't be a hero. We're happy to troubleshoot code in any of the 3 packages that are working on this. All right, then how about we call it a day? Go enjoy the sunshine. Let us know if we need anything. And thanks for coming. Bye for now.